Permutations is a way of coming up with the possible ways to figure out a total number of outcomes given a certain type of situation. And that situation is when you need to arrange objects where the order matters and there is no repetition of objects. This number that we get is always going to be a whole number. We're not going to end up with 237.5 ways to roll a die, flip a quarter, and spin the roulette wheel. That's not going to happen. There was going to be either 237 or there's going to be 238. There's no possible way to get a fractional way of doing something. So just keep that in mind as you're working with permutations. It's always going to be a whole number. There's a formula that we write, and it's denoted as little n, big P, and little r. The little n is for total number of objects. The little p is, or not the little p, but the little r is number in the arrangement. And the big P represents what we're talking about, and we are talking about permutations. So it's the formula that you're going to use, and the formula that you're going to use is n factorial divided by n minus r factorial. So we're going to need to use our notion of factorial from the factorial video, where it's the number times all the smaller numbers below that up to 1. Let's take a look at a possible example. It's arrangement of objects where order matters and there's no repetition of objects. If we go ahead and take a look at the next page here, we have an art exhibit, and Craig has to choose 3 ceramic mugs out of the 7 that he has made over the summer. And how many ways can he arrange these 3 mugs in a row? So think of it as, here's a shelf. I'm going to put mug number 1, mug number 2, mug number 3. He's created them all. They're all different sizes. They're different shapes. He's created them over the summertime. We need to arrange these for him, and he wants to be able to make 3. He wants to be able to choose 3 of them out of the 7, but he only wants to pick 3. So if we pick one here, we want to go ahead and use a permutation because we don't want to repeat them. But we do want to make sure that the order matters, because if we pick the first one, then we can't pick the second one and repeat it, because it's already a mug and it's already been arranged as part of the arrangement into the art exhibit. So I'm going to take a look at the total number, 7, P, 3, it's the total number of objects, permutations, and 3 is the number of objects that we want to pick. If we apply our formula that says n factorial over n minus r factorial, that's the big number 7 factorial, divided by 7 minus 4 factorial, and I now have 7. Oh, that's 7 minus 4, crazy. Thinking of the answer, 7 minus 3, which gives me 7 times 6 times 5 times 4 factorial over 4 factorial on the bottom. That's 7 take away 3. I did my shorthand notation so that I could go ahead and cancel out. I now have 7 times 6 times 5. 6 times 5 is 30. 30 times 7 is 210. So I have 210 total ways to go ahead and arrange these mugs for Craig on the at the art exhibit. If next I go ahead and take a look at the members of a track team who want to choose a team captain and someone to organize their equipment. So I need a captain and I need an equipment manager. In how many ways can 2 people be chosen from a team of 10 girls? So I want to pick 2 of these people. These 2 people, one of them needs to be captain, one of them needs to be the equipment manager. Can't repeat the objects, and the order does matter because if I first pick them to be a captain, then I can't go ahead and pick them to be the equipment manager because that person can't do the same thing. And we're gonna, if we flip it around, we'll pick them the same way. That will be picked. So here we go. We've got a 10 P2, and we're gonna go ahead and put 10 factorial on top over 8 minus 2 factorial on bottom. I did it again. How about 10 minus 2 factorial on the bottom? So that I can go ahead and say 10 times 9 times 8 factorial over 8 factorial. Do the shorthand way, cancel it off. 8 can be gotten rid of with 8. So I now have 90 ways for us to choose the 2 people on the track team to be in captain or the equipment manager. Next one is another word problem. If a teacher is passing out first, second, and third place prizes for the best student actor in a production of Hamlet, if there are 14 students in the class, in how many different ways can the awards be presented? This is pretty simple to see here that order matters because we've got first, second, and the third place winner. So when I'm going to go ahead and look at this, there are 14 total students. I'm going to permutation them with picking 3. Use my formula, n factorial over n minus r factorial, and it is 14 factorial over 14 take away 3 factorial, and I got it right that time. So that's 14 times 13 times 12 times 11 factorial over 11 factorial. Anywhere to stop on the top because I took a look at the bottom and did 14 minus 3 first. Knew that I was going to get 11 so that I could do my shorthand notation and not have to continue to write out all the numbers for 11 on both top and bottom. Cancel the 11s. I've got 14 times 13 times 12. If I want to go ahead and look up what 14 times 13 times 12 is, I could use my calculator, or if I have to, do the old school. 2 times 3 is 6. 2 times 1 is 2. Add 1 is 3. Put a 0. 3 and a 1. That makes 166. And then I got to do 166 times 14. 4 times 6 is 24. 4 times 6 is 24, plus 2 is 26. 4 times 1, that's 6. I'm going to add that 2 on there, and then I'm going to make sure I put a 0 in the placeholder. 1 times 6 is 6. 1 times 6 and 1 times 1. 4, 12, 13, and 2. So I've got 2,324 ways that that teacher could give out first, second, and third place prizes to her class.